Hey guys, so this is the second video of the transformation video set, and your group is only responsible for watching this video, and then you should learn the other pieces of information from the other groups. However, I will post all the videos if there's something you want to go back and look at. All right. So we're talking about transformations here, and your learning target is 4G. I can perform transformations of parent functions. So we learned about all the different parent functions last class, and now we're going to take those parent functions and we're going to be able to move them around our graph or change the way that they look so that we can create new functions from them. So think of those as like the mama and the papa functions, and then all the other functions that we have are the little baby functions, which resemble those parent functions closely, but they're a little bit different. Okay. So the topic for your group is translations, and specifically horizontal shifts. All right. So let's go through and see if we can fill in some of this information. All functions are based off of or based on the parent functions. All right. And when we're doing transformations, we're going to start with the parent function, and then we can perform transformations to change the function. So just like I said, what we're going to be doing is manipulating those basic parent functions, which are all centered at 0. They have a standard, slope. There's no stretching or shrinking or moving around that's happened. We're going to do all that with the transformations, and one of the transformations we can do is a translation. All right, so you might remember this type of vocabulary from geometry. You did this with shapes back in geometry. We're going to do it with functions now. So a translation is also known as a slide, right? So in your particular case, because it's a horizontal shift or horizontal translation, horizontal is that direction, so we're going to be shifting those graphs left to right, okay? So we're going to take whatever function it is that we're given, and we're moving it as a translation. We're sliding that graph. There are two types of translations. The first one is a a vertical shift that the first group is learning about, and you guys are going to be learning about horizontal shifts. This will cause the parent function to move left or right on your graph, okay? So from 0, 0, it'll either be shifted a little bit to the left or a little bit to the right. We're going to cause this to happen by adding or subtracting a number inside of the function. So one of the ways that we can represent that is by, instead of just writing f of x, is to add or subtract a number in with the x value. So inside of those parentheses, and when I say inside the function, there might not be parentheses showing up in your actual equation of the function, but you want to keep it either inside of the exponent or inside of the function symbol, whatever that may be. Okay, and we'll look at some examples in a second. One important note is that the graph moves the opposite direction of the sign of c. So if inside your function you have plus c, like plus 5, x plus 5, okay, that's going to move your graph actually to the left c spaces. So it moves opposite of what you see. And the reason is technically our formula is x minus c. And so if it was really a negative c that you put in there, well, minus a negative actually makes it look like a positive. So it's a little deceiving. Things that happen inside the function are often their inverse. You see the inverse happening. And so a minus c, like a minus 5, would actually move to the right C spaces. Okay, so let's check that out with a few examples. So we're going to apply this to the quadratic function. So we need to remember, what's the equation for the quadratic function? Well, the basic equation would be f of x equals x squared, power of 2 for quadratic. And this is saying move the function 3 spaces to the left. That's my first directive. So we need to go inside the function, which if we're just being general about it, we can do f of x, but then inside of those parentheses, if we want to go 3 spaces to the left is going to look like a positive. So we would actually see plus 3. So that's being really general, as if we didn't know what the equation was, but we do. We know it's f of x equals x squared. So I can actually write this as inside the function, I'm going to keep in parentheses x plus 3. That's telling me, hey, take that graph and move it 3 spaces to the left. And because it's a quadratic function, I need the power that created that. So 2, the power of 2 is going to go on the outside of those parentheses. It's important I put the parentheses in so I know that x plus 3 is grouped together. Let's look at what that looks like here, actually, on Desmos. So if we start with our parent function, x squared, right? There's your parabola. Okay. And now we want to do, in parentheses, x plus 3, close the parentheses, squared. Right? So look at where that graph moved. It's now 3 spaces to the left of 0 instead of at 0, 0. If we had just done x squared plus 3, that actually moved the graph up. It didn't move the graph to the left. So it's important that you include that inside the parentheses there. Otherwise, we won't get the right movement. Okay? So let's look at the next one. It says move the function 6 spaces to the right. So the right is going to be minus. So we could do f of x minus 6. But we know what f of x is, so let's be a little more specific. Inside my parentheses, to put it in the function, x minus 6, and then put the power outside so we know what the function is. So let's go back here. X minus 6 squared. Now you can see that that parabola shifted 6 spaces to the right. Okay. Let's try a different one. What about absolute value function? So all these same rules apply for any of the parent functions. Well, our absolute value equation is f of x equals the absolute value of x. And this is saying, oops, move the function 31 spaces to the right. All right, so again, generally, we could do x, if we're going to the right, it's opposite, so minus 31. Or, because we know specifically what the function is, we can do f of x equals, open the absolute value symbol, and x minus 31 should go inside the absolute value symbol. All right. So here, if I just have absolute value of x, we get that V-shape graph. If I do absolute value of x minus 31, well, look all the way over here at 31 is the same V-shape, just been shifted to the right. Okay. And then lastly, let's try for the square root function. So the square root function is f of x equals the square root of x. We want to move the function 2.8 spaces to the left. So f of x, if we're going to the left, I want it to say plus, the opposite. So plus 2.8. F of x is equal to, well, the square root symbol is enclosing the function. So whatever I want to move left or right has to be inside of that symbol. So it would need to be x plus 2.8, and make sure the square root symbol goes all the way to the end of the 2.8. Okay. Otherwise, again, it would shift it up and down and not left and right. So there you have it.